Course 3, today's lesson mentions and works with scatter plots. I don't know that we spent a lot of time with these. They might have been an investigation we skipped past. But a scatter plot basically plots dots that are not going to be perfectly linear. It's not a straight line. But if there is a correlation, they will gather around a trend line that will help us understand the relationship between two variables, the one being charted by the x-axis and the one being charted by the y. As you can see in the three pictures, you can have a positive correlation, which means one variable increases while the other variable also increases, which results in what generally, again, not a perfect line, but generally plots out to become what we would normally think of as a positive slope line. Negative correlation, the opposite, where you've got one variable increasing, so we have the x variable. As the x moves along, the y is going down. So the x is increasing, but the y is decreasing. This might be the number of hours a student spends watching TV and the student's grade point average. I appreciate that graph. Something to keep in mind during this quarantine. And then finally, no correlation. There is no trend line that can be drawn there. You can't tell if it would be positive or negative. It may not be that far apart. You might have a little better than that. That's about the least correlation you could possibly have. But that would be like trying to chart on the x-axis a student's address numbers, like 303, as in our school's address. And then the y-axis is your grade point average. We don't really use those, but like 3.5. There's no correlation. You're not going to find that kids with a certain address always have a certain GPA. There's not going to be any correlation there. They're two completely random variables. An example is if we were charting on the y-axis the mass of an object, so grams, from 0 to 30 there. And then the volume, which could be measured in cubic centimeters. As you can tell, it's not exact, as a lot of real-world measurements, especially in science, may not be perfectly exact, but there is definitely a correlation here, is there not? You can see this is not going to create a perfect line, but letter A says draw a line of best fit. That would mean a trend line where you start in one spot and you kind of just draw it so it's touching as many of the dots as possible. And I'd say that's a pretty good line of best fit. Again, these are only going to have to be close because everyone might have a slightly different line, but you're just trying to make it follow the trend illustrated by the pattern of dots. And I think I did a decent job. Now use that line to come up with a prediction for what the mass would be, which is going this way, right? Up and down y-axis. What that would be for a specimen with 100 centimeters cubed volume. Volume being charted this way. What's the problem? Our current graph only goes to 10. So how could we answer something like that? You might have expected it to ask just, what would you expect? What would be an estimate for the mass of an object that has a density of 8 cubic centimeters? And we could go to 8, and maybe I'll draw a line up from 8 to our trend line. And you'd say, you know what? It looks like it's about 22.5, or maybe 23. I'd allow anything around 22, 23. They go one step further and they say, what if it was like 100, which I know this is not to scale, but way out here. How could we solve that? Well, if you think about it, if we can find what it is at 10, looks like it's about 27 here. Okay, if it's about 27 on our trend line here, oh, here we go. It's about 27 when it's 10, right? It's about 27 when the x is 10. So x is 10, y is 27. Well, then if x is 100 and if it follows a trend, what could we say the y might end up being, right? It's going to be somewhere way up here. Well, then I'd expect that to be also, right? What's the constant factor? It's times 10. So just multiply this by 10. So I'd expect the mass to be, I don't know, 270 grams. You follow me? When it's 100 centimeters cubed. Incidentally, we are also using the slope, right? Rise over run. So 27 divided by 10, the slope is really like 2.7 here. Because when I rise 27, we said the run is about 10, which divides to be 2.7. So in slope intercept, we've got y equals slope, m, 2.7, x. I don't think there's a y-intercept. I'd say it's about 0, 0, so plus 0. Well, you could substitute in the x, which we said, well, what if it's 100, right, way out here? And we end up doing the same thing. Well, then with the slope, what does the y end up being? See how we do that? So I kind of followed it with just logic that if it's 10, then we just follow the constant factor, but you could also use slope-intercept the way I just showed you. Feel free to quick read through using scatter plots to make predictions. It's an interesting one where they're comparing number of vowels to the total number of letters. And they say because that whole activity is kind of involved, and I think we just did everything we really need to be able to do with that example 1, there is no lesson practice. So, Merry Christmas.